We are the senior design team developing a non-contact electromyography system. Team members include Christy, Park, Jacob, Jeremiah, and Tyler. EMG systems record muscle activity by measuring the bioelectrical signals generated by nerve and muscle cells. They can detect damaged nerves and muscles by looking for abnormalities like random spiking caused by muscle imbalances or dysfunction. These signals are picked up by the electrodes, which are small sensors placed on the muscle. Our team has developed a wearable, non-contact electromyography system that uses capacitive coupling to measure signals generated by the bicep through a layer of cloth. Traditional EMG systems rely on wet electrodes, as shown over here, which require a gel and must be placed directly on the skin. However, these types of electrodes have several limitations, including reduced long-term wearability, frequent replacement, limited applicability, and potential skin irritation. Our system is designed to overcome these limitations using capacitive electrodes and wireless connectivity for real-time monitoring, while maintaining an accurate signal. The bioelectrical signals in the bicep are extremely small, typically on the orders of tens to hundreds of microvolts. This makes signal detection extremely challenging, as it requires careful amplification and filtering to capture the desired signal while minimizing noise. A differential measurement is first collected from two locations on the bicep, using two small 20 mm electrode PCBs, providing front-end stabilization, buffering, and amplification of the signal. This signal is then further amplified and filtered on the main PCB before being digitized by an ADC and transmitted wirelessly via ESP32 Bluetooth. Finally, the data is digitally filtered and visualized in real time using MATLAB. Moving forward, our next steps are to evaluate the signal quality of our capacitive system by replacing the capacitive electrodes with standard wet electrodes for comparison. We also plan to expand testing. Currently, we have only tested our system on ourselves during light bicep contractions. One of the main benefits of our system is that it's wearable and wireless, and so it can be used during activities where being physically connected to a wired system is not practical. Expanding the range of testing conditions, increasing the activity level, and broadening the variety of test subjects will give us more and better data and help us determine areas for improvement. We could also expand our system by adding another channel. Currently, we are capturing a very small area of the bicep using a single channel, which uses two electrodes. Adding an additional channel or two additional electrodes would allow us to capture more activity across the bicep and can be used to improve the signal quality by comparing it with the original channel to help us identify and reduce common noise. This project was internally sponsored by Michigan Tech's Electrical and Computer Engineering Department. We'd like to thank our advisor, Dr. Choi, as well as Dr. Pinar for their guidance and support throughout this project. Thank you for watching.